Welcome back to the fourth episode in the playlist. Today we're going to be covering subnetting, all right? So let's get stuck into it. So I've got some examples here. We're going to follow along. We're going to sort of understand what it is in depth. Okay? Let's go. All right, so subnetting, here's like a visualization of it. It's basically breaking networks into more networks. And this is done by subnetting. So you're creating subnets. So think if you have a main network and then you have more networks derived from it, ergo sub. So it's the subnet of a network, etc. But here you can see we've /26, which we did before we looked at CIDR notation, which just means this network actually has borrowed two bits for the subnet, which is going to be 2 to the power of 2, which is 4 networks. So, but we'll go into how that works and understand that. But basically, the main premise is you're sort of deriving networks from a network, and that's done by subnetting. Okay, that's what it's called. So here's a little picture I've got here. So the practice of dividing a network into 2 or more networks is called subnetting. So we have our network right here. For this first one, you can see, and they sort of represent it in like a linear line here. And when you subnet, you've essentially created 2 networks. So you have this subnet and then you have this subnet. So this one starts at this and this one starts at this this IP address. Does that make sense? We'll get into how it works in a second, but you're basically splitting it off into 2 or more. And that's what a subnet is, okay? So we're going to cover these questions over here. So number 1, number 2, number 3, number 4. And we've already went over this. So splitting a network and address range into smaller networks, and result is multiple sub networks. Okay, that light is very bright. It's hurting my eyes. Okay. All right. So, purpose of subnetting to enable the reduction and management of broadcast domains, to reduce congestion by allowing fewer devices in a subnet, to divide a network into logical subnets, departments, divisions, staff, visitors. We've also got to support different network technologies, Ethernet, Wi-Fi, etc. To support wide area networks by allowing geographical separated LANs to use a single network ID. Okay, so you got your main network ID here, and then what's that equal to is multiple networks along this line according to this specific example. But sometimes you may have larger number of IP addresses to manage. Break the host ID portion of the IP address into the subnet and host ID. So here we went over this last time. We have our network portion and our host portion, and this is a little red thing. This is just saying, where's our network, where's our host? And to create subnets, you need to basically give more bits to the network side so you can create more networks. Okay, but it's hard to sort of explain like that, but we'll get into it. So if you look here, this bit's going to be used for the subnetting. So we're going to be borrowing bits from the host portion, most typically, and then always, and then that's going to give us more subnets. Okay. So it can get confusing when there's all these different things. We've gone through class B, class A, and all these different networks, and you have all these different portions. But just try and stay on track with me, and we can sort of understand it. So a subnet mask 255.255.255 applied to the class B address will break the host ID, normally 16 bits, into the 8-bit subnet ID and 8-bit host ID. So this bit is our network portion. This is our subnetting portion. This is our host portion. So this is actually creating a lot of subnets. Okay. Now changes from 2-level addresses structure to 3-level address structure. So external networks do not know about subnet host ID details. They only see a single network. So when you create a subnet, your external networks are only going to know about the main network, not the subnet. So if you've got a /24 base network and you've subnetted it, the /24 is what's going to be known and seen, visible. So use a definable subnet host ID boundary. So as you can see here, as I said before, when you subnet, you take portions from the host ID section and that becomes your subnet ID. And that will tell you how many subnets you have. So without subnetting, you have network ID, network access. Okay, this address point, blah, blah, blah. So that is obviously a 255 class C network with subnetting. 4 subnets required. So we need 4 subnets. So what do we need to do? We then need to, well, in this example, these are potential 4 subnets here, 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 here. But we've essentially borrowed 2 bits from the network portion to create this, from the host ID portion to create this. And that's going to give us these networks right here. Okay. So the whole network is seen as 193.2.1.0. You've obviously subnetted it /26. It becomes this. Okay, and this is your boundaries. This is an example of the same one, but visualized differently. So if you can see here, same thing, just visualized in a different way. Okay, and yeah. All right. So what is the subnet mask of this one? I'll give you guys a test. The subnet mask is, well, .192. The reason it's 192 is because we've borrowed 2 bits from the host portion. Now, when we were doing the examples before, it was 255.255.255.0, and that was our class C. But we've borrowed. It's still a class C network, but we've borrowed bits, meaning we've subnetted on the host portion. So, if we borrowed 2 bits, it's 192 plus 64, which is, well, 128 plus 64, which is 192. And we've got 4 subnets from this, and then we have 62 valid addresses to use in the network, which is like, yeah. Does that make sense? Okay. So that's just saying how many hosts are in each one. And you have to obviously have to -2 because each one you have to factor in network and broadcast, which we went over before. So to decide how to derive the subnet mask, decide how many subnets you need. So that's the first thing you need. You got to define how many departments, how many this or that do we need. Okay, and that's usually done by looking at the question or whatever you've been given and saying how many do we need. So maybe you need like a one for your science team, your math team, and your geography team. So that's 3 subnets, but you can only use in increments of 2, 4, 8, 16, etc., etc. So you'd have to use 4 as your subnet, how many subnets you'd have, and that can accommodate for 3. So there'd be one that's not used, which is dead space, but it's the best you can do. Decide how many bits you need to meet or exceed the number of required subnets. So we're using that formula 2 to the power of n, and representing the number of bits you add to the starting subnet mask. So you borrow bits from the top of the host portion of the network address down. So if you had the network address here, you have your host ID, you have your network portion and your host ID portion. You borrow from the first host ID portion that's closest to the, how should I put this? Closest to the network side. Okay. So ensure that you have enough host bits available to assign to a computer in each subnet. And then that's going to be done using that calculation 2n to the -2. And you can do that by checking how many hosts bits you have, and then that you just plug in the host bits to 2 to the power of and then -2. So when you create a non-default subnet mask, you're borrowing 2 or more bits and asking IP to interpret them as network bits. Example, creating 4 subnets in a class C address and figuring out the subnet mask value. So you're going to need to borrow 2 to create 4. That's going to do this. Well, actually, yeah. So initially the class C address is 24 bits and 8 host ID bits. 24 bits for the network ID, sorry. Step 2, you subnet the address, 24 network bits, 2 bits for the subnet ID, and 6 bits for the host ID. So this creates 4 subnets with a total of 62 potential hosts that are usable. Obviously, there's 64 in the sense that you have your broadcast and your network, but 62 usable. And in terms of a network address or no subnet mask, it would look like this. We've borrowed bits on the host ID portion, meaning our subnet mask is now going to be 255, 255, 255, 192, because that's 128 plus 64. Okay? Now, valid IP addresses in a subnet. Host bits can not all be 0 because obviously there would not be a subnet. You have to have ones in there to get the subnet. Otherwise, you haven't subnetted anything. Does that make sense? So host ID bits cannot all be 1 because that would be the broadcast address, and that would not work. So broadcast address are used to send packets to all hosts within the subnet. Okay, so you can't touch that. Let's look at this example for now. So we've subnetted 2 bits on the host ID portion, which means 2 to the power of 2, which is 4, meaning we have 4 subnets. So if you look here, we've got subnet 1, subnet 2, subnet 3, subnet 4. And each extending to a different sort of amount. So this one over here is going to be 1 to 63, 65 to 127, and 127. And then we got 129 to 191, and then 192, all the way up to 255, I think it is, unusable. Yeah. So, as you can see here, this is invalid because that is your broadcast and this is your network address. So those aren't usable, but anything in between that can be used. And then you've got unusable, because those are your network and then broadcast. Same thing for the next one, same thing for the next one that goes to 255, yeah. And yeah, that's it. That's the logic behind that. So your ISP is allocated a block of addresses. This is going to be a question we're going to do together, actually. I'll get my pen and paper out, put this down here. So your ISP has given you a block of addresses, right? Let's write this down. So 193.64. Actually, I'll get a Word document so you guys can see, because that would make a lot more sense. But I'm gonna put it right on the side like that, and then we'll go here. We'll find that question I had, so you guys can follow along with me. So we've got a network of 193.64.33.0/24. Okay. Now, your organization needs to have 8 subnets for this its structure. So we need to work out the subnet mask. So we need 8 potential subnets. So can we do that? Can we accommodate 8? So let's just try some different things. So what's 2 to the power of 3, okay? So 2 to the power of 3, 2 times 2 times 2, which is 4 times 8. So 2 to the 3 can work. Now, that means we're going to need 3 bits, okay? So that means we're going to have to borrow 3 bits. And what would this mean? This would then mean we'd be operating on a 193.64.33.0/27 network as our main network, which would be visible. And that's what it would look like to accommodate for this subnet. So the subnet mask of this would actually be 255.255.255. So that's 3 bits. So that's 128 plus 64 plus 32. So 192 plus 32. 1. That's actually 224. So it's 224. That's a subnet mask. And then we have our, I'll just write this. So subnet mask. We have our, this is our a side notation of what it would look like with the network address. But obviously this can be represented as a /26, like the subnet mask, as you can see. And we'll show the subnets. I hope you guys can follow along and see clearly what I'm doing. Okay? So the subnets that we're going to have are 193.64.33.0. We're going to have 193.64 plus 33. So this is going to give us a potential host amount So it's going to be okay, so it's going to be 2 to the power of 5. Now, 2, 2, 2, 2, 4, 8, 16, 32. 1, 2, 3, 4, 5. I believe it should be 32. I'll just confirm that right here in the sense that we're moving in increments of 32 for each subnet. So we'll just go, where's me thingo? Yeah, exactly. So it is 32. I'm just want to confirm to make sure I'm not gonna like make you guys follow the wrong thing. So then that's our next one. Our next one's obviously going to be .64, blah blah blah, and until we fill out 8. So it'd be this thing plus the increment of dot. You know, I'll just go and do that. I'll just add this one here, and that would extend all the way to your 8th subnet. And then the valid would be, well, this one would be, 1 to 30, 30. And then you'd have, for this one, it would be 30, 33 to 62. And then we can confirm that here. But anyway, that should make sense to you guys. So we'll confirm that down here. And we'll go here. And then it should be, 1 to 30, 33 to 62, etc. Okay? So I don't think that was too hard. I just went through it with you guys. If you want to go over that again, you can look at that again. But that's just the basics of subnetting. So you have the question, like you need 8 subnets, and then you do accordingly to that. Okay? VLSM variable length subnetting. So what this one is, it's pretty much the same as doing subnetting, but you're basically subnetting a subnet. And it sounds confusing at the start. Trust me, it's not too bad, but you're basically, dividing a subnet into another subnet, if that makes sense. So we'll go over this and how to do it. Okay. So suppose we have a class C address, so 212.5.5.0. We require 3 subnets, right? So 3 subnets with 60 hosts and 2 subnets with 30 hosts. So the first thing you do with the VLSM, variable length subnetting, is you start with the biggest to the smallest requirement. So if you can see here, we require 3 subnets. Now, if we require 3 subnets, we have to create 4 subnets because we can't create 3 due to the fact that 2 to the power of 1, right, is not going to work. 2 to the power of 2 is going to work, and that's 4. So 2 times 2 is 4. Okay? So if we do 2 to the power of 2, which is 4, that's going to accommodate for 3 subnets with 60 hosts. Now, we don't need to worry about the 2 with 30 yet, but that's going to be something we will do. So if you can see here, we've created 4 subnets, which means we've approximately borrowed 2 subnet bits from the host portion, which means that there's 4 subnets. Now, ignore this section here, but we have 4 right now, okay? So as you can see, there's 1, 2, 3, 4. And if we have 4 subnets, it means that we have a /26 network. Now, in the example before we had a /27 network, which had 32 potential hosts. So we're now using a /26, which means we now have 64 potentials, okay? So for each category, we have 64, which accommodates our 60 hosts requirement here. So that's perfect. We're going to borrow 2 bits, and then we're going to further subnet this. So by doing the first thing of subnetting the first step, which is taking 2 bits, we have accommodated for this section right here. Now, with our last subnet, we're further going to split that into a /27, I think it is. Yeah, /27. So you're going to have these ones here, and you're going to have this one, which is split off into this, which is going to accommodate for an extra 2 with 30 hosts. Because if it's /27, you have potential of 32. Obviously, 32 minus 2 is going to be 30, which is going to fit this perfectly. So you're basically subnetting a subnet, and you have to start with the biggest requirement to the smallest, and then you'll obviously subnet your last one, so a hashtag for subnet. Okay, so we'll go over it right now into a visualization. Not a visualization, like the text of what I've done for it. So the original subnet mask for this Class C network is, 255.255.255.0, which is equivalent to 24 bits. The new subnet mask is .92 because we've borrowed 2 bits, right? Now, let's calculate the new subnets. So the first 3 are going to be, like if you look at this example, the first 3 are going to be the same in terms of how much we're moving up incrementally, which is going to be moving up in terms of 64. So moving up 64, moving up 64, and we're using 60 hosts in each one, okay? And then for the bit that requires 2 subnets and then 30 hosts, that one's right here. And that's actually the 4th network, which has been cut up. It was originally a 2.6 network, but it was cut up into a 2.7 because we've subnetted it further, which can then accommodate for the the extra, the 30 ones that we have here. So that's this network, that's that network, that's this, and they're all separate different networks, but they will all be registered under this top first one. But yeah. So this way you have 3 subnets with 60 hosts each, and 2 subnets with 30 hosts, meeting the specified requirements. Okay. Now let's take this example for an example here. This one's going to be a good example we can follow. So actually, I'll just go back here so we can do it together on this Word document. So we have a company called Healthcare Industries, which is the address of 192.21.42.0/24. Right now, the subnet mask is 255.255.255.0. We have guess 10 robots, this. So those are our requirements. So we're going to start at our biggest thing first, which is going to be our workers, which equal to 117. We've got our robots, each one 57. We've got our servers, which equal to 26. We've got our guests, which equal to 10. So what we'll do here is we'll just add this up, right, to see how many total sort of hosts we need. And obviously I did the calculation before and it's 210. So total hosts needed, I guess it's 210. So the first thing we're going to do is we're really going to just run through this and figure out, well, we need 4 subnets, okay? Well, actually, there's no need to worry about that at the start. We need to figure out what can accommodate 117 workers, okay? So let's figure this out. 2 times 2 times 2 times 2 times 2 times 2 times 2. So that's 8, that's 4, 8, 16, 32, 64, 128. 1, 2, 3, 4, 5, 6, 7. So that's going to be 7 bits. So hold the phone. Okay, so that's going to be 7 bits which need to be reserved for the host portion for the start. Meaning we're going to subnet with a subnet ID of 1 in the first network. Okay, so for workers right here, we're going to do we're going to do a /25, and actually I'll write out the network, I guess you could do 172.21.42.0/25. Okay, and now I'll go here, and what this will put us up to is essentially 172. Actually, I'll go and I'll do this so you can see 172.21.42.128. Because we've borrowed 1 bit, meaning our subnet mask will now change to this .128. Okay, that's for the first one. So this is our workers. This is going to be its network. And then the next one we have to do is robots. So we are obviously now starting from this network right here. Actually, I need to change that. That needs to go to 7. So make sure. Yeah, okay, cool. So I'm just gonna make sure I'm not gonna deter you guys and make you guys get the wrong answers. Now this one's gonna be a bit more tricky because we're gonna have to now accommodate for, well, 57 hosts. And we know that we are moving up in increments of 64, 32. So therefore we need 62. Now 62 is taking a further bit. So now we're going to operate on this network. So 172.21.42.128 plus, let me just grab this bad boy. Make sure everything's all good. 128 plus 64, which is 192/26. Our address is 255.255.255.192. Okay. So what happens now? Well, actually, this needs to go to 191 because that's of what we're going to be able to use. This is broadcast, that's network, okay? And now that means our next one is 172.21.42.192, spanning over to 171. Is it 172.21.42 point? And now we need to remove increments of 32. So 192 plus 32 is 224. 224/27. And a /27 because we need 30. We need 26 hosts, and the best we can do that with is 32. Okay, which is going to be borrowing 5 bits, which means we have 3. So 3 plus 24 is 27. Therefore, our CIDR notation is 27. And I'll draw the subnet mask out in a second, which is 255.255.255. And it's, 128 plus 64 plus 32, which is 224.224. And that has to change to 223 because that's not what we're going to use. And then this can change like this. I'll also confirm the answers to make sure everything's all right in a second, so I don't make you guys get the wrong answers. And then now the last one. So we're going to do, well, I'm going to let you guys think about this one. So give it a second, pause the video, and give that a crack. All right, so we're actually going to have to borrow 16 to accommodate this one. So, which means, in the sense that we need 16 hosts. Now, 16 hosts means we need to borrow 4 bits. Now it's going to be /28. Okay, so 172.21.42.224 going upwards to 172.21.42. Now 224/16, which is 240. Okay, now that's going to be slash. It's actually going to be 31 because of what we can use. And then we got /28 for this one because we're borrowing 4. Okay, so these are going to be our networks, 255.255.255. And then we've got, the 240s down here. So I'll confirm the answers here with you guys. Make sure we go right. So the guess for the first, this one we had, our network was /28 and it was 224, correct? Our robots was /26 and it was a 128, correct? Servers was a 192. Down here, 192/27, and 25 workers was this one, which is on a 0. Okay, that is all good. So we've split the networks up, and that's how it's done. Here's the sheet of paper if you want to look at that again, and you can go through the thought process I went through before to get that. The next one we got is supernetting, which is the opposite of subnetting. but we'll be able to work through it because if you guys follow this video, you'll be able to get through it. All right. Catch you guys next time. Have a good one.